Okay, so now we're going to look at exponential and logarithmic equations. So solving equations with logs in them, we're going to use these steps. Here's just our property. If x is equal to y, it's equivalent to log base a of x is equal to the log base a of y. And I just have a few steps here for solving equations with the exponential functions. Isolate the exponential function. If convenient, express both sides with a common base. We practiced this in a previous lesson. Otherwise, take the natural log of both sides and solve using the power rule. So let's just see a few examples to get a better understanding of this. In the past, we would try to write this base and this base to match. Well, this smallest base is a 3, and there is no way that I can rewrite 10 to have a base 3. There's no option for that, which is part A. It says if it's convenient, have a common base. If it's not, we got to do part B. So this one, 3 and 10, could not possibly give me a common base, so I'm going to take the natural log of both sides. Take the ln of both sides because it told me to use the natural log of both sides. So what I'm looking at would be the ln of 3x is equal to the ln of 10, so the natural log. ln of, 3 to the x. Let me make sure get that on the right level. Take the natural log of both sides. Now our power rule says, remember, if we have an exponent, we can bring it out front. That's a property we practiced with in the previous lesson. So we would say x natural log of 3 is equal to the natural log of 10. And then we want to get x by itself. If this is multiplied by x, we want to get x by itself. So we divide both sides by the natural log of 3. And that will give us x is equal to. This is considered your exact answer. And if I put this in the calculator, natural log of 10, divide by natural log of 3, the decimal would be x is approximately 2.096. And this is an approximate value, approximately. So if it asks for sometimes your homework asks for 2 parts. Sometimes it asks for the exact value, and sometimes it asks for an approximate value. So it just depends on what it's looking for. All right, 1/3 and 5. I cannot make either of these rewrite with a common base of those two values. So I'm going to use my natural log method. So I'm going to say natural log of 1/3 to the x is equal to the natural log of 5. And just like in the previous problem, we can use the power rule to move the exponent out front. So that would just give me x natural log of 1/3 is equal to the natural log of 5. And then we're solving to get x by itself. So divide both sides by the natural log of 1/3. This would cancel. X is equal to natural log of 5 divided by natural log of 1/3. That's my exact answer. And then if they said to the nearest thousandths, it wants my approximate answer. So then I would plug that in the calculator and get negative 1.465 approximately. Alright, a base of a 4 and a base of a 3. I'm not able to rewrite those using like bases, so I'm going to take the natural log of both sides. Okay, I want you to use the power rule to pull that out front and see if you can solve the rest of this. So this would be out front, so I'm just going to have x minus 1 natural log of 4. This would be out front using the power rule, 2x natural log of 3. Now, we have a parenthesis over here, so we need to distribute this out. So I'm going to say distribute here, x natural log of 4, and then I'm going to have -1 natural log of 4 is equal to 2x natural log of 3. Now, ultimately, our goal is solving for x, so we can't get lost. I have an x in this term right here, and I have an x in this term right here. So what we want to do is we want to move everything that has an x in it over to one side and everything that does not have an x in it to the other side. So I'm going to cover over this so we can write. So I'm going to bring down x natural log of 4. That's this term. Bringing it down equals. This term does not have an x in it, so I want to move it across to the other side of the equal sign. So if it's negative natural log of 4 and I move it to the other side, it's positive natural log of 4. So I've taken care of that one. And then this term has an x in it, so I want to move it to this side and it becomes -2 natural log of 3, because when you take something from this side of the equal sign and you move it to the other, you change the sign. So what I've done is I want to take a common factor of an x out. So if I take x out of this first term, I have natural log of 4 left. If I divide an x out of this term, I'm going to have 2 natural log of 3 left. And I just carry this side down. If you're solving for x, so basically what we did was we factored out an x here. And when we're solving for x, we're going to divide by this entire parenthesis. Divide both sides by this entire parenthesis. Whatever you do to one side, you're going to do to the other. And so this cancels this, and I would get x is equal to this value. That's my exact value. And then I would plug it in the calculator to get an approximate value of -1.710. So this is your exact, and this is your approximate. Let me just go back and briefly explain that again. The bases are not the same. I can't write them with a common base, so I took the natural log of both sides. Use power rule to move the exponent out front. Power rule to move the exponent out front. Distributed my parenthesis out on this side. And at this point, I moved every term that had an x to the left, and every term that did not have an x, I moved it to the other side of the equal sign. I factored an x out of this and wrote what was left over, and then divided both sides by that to get this value. This is my exact value, and this is my approximate. Alright, it'll help to see it again. So 6 and 4, we cannot rewrite those to have a similar base, so we want to take the natural log of both sides. So I'm going to say natural log of 6 to the x plus 1 power is equal to the natural log of 4 to the 2x minus 1 power. Our power rule says we can move this out front and this, so that's our next step. So I'm going to say parenthesis x plus 1 natural log of 6 parenthesis 2x minus 1 natural log of 4. Okay, at that point we're going to distribute. So I'm going to say x natural log of 6 plus 1 natural log of 6 2x natural log of 4 minus the natural log of 4. Okay, once we have everything distributed out, we want everything that has an x term in it. This one has an x, this one has an x. We need these to be on the left, and everything that does not, all the terms that do not have an x in it, we want to move those to the right. So if you'll let me just rearrange, I'm going to have x natural log of 6 minus 2x natural log of 4, and that's just because I moved this one across the equal sign to this side. Equals, I'm going to bring this one down, negative natural log of 4, and then I'm going to move this one to the other side. So all we did is we shifted everything. The two terms that have x's in them, I moved them to the left, and the terms that do not, I moved them to the right. And now I want to factor out an x. I'm going to say if I divide x out of this one, I would just have natural log of 6 left. If I divide x out of this one, I would have negative 2 natural log of 4 left. And then I just carry this side down. To get x by itself, we'll divide both sides by our parenthesis. And this is our exact value. We would put that in the calculator and get x is approximately 3.240. So this is your exact answer and this is your approximate answer.